Okay, welcome back. And we'll have a look at indices as a separate file, and we'll have a look at the remainder of the lesson also as a separate file. So, what are indices? What's the name of indexes? If you're asked the question, what's an index? How do you describe an index? Now, I went through the lecture a little bit, asking people questions, a lot of blank faces. So, what we're just reminding ourselves is that the vocabulary is important. Okay? It's just a shorthand for multiplication. That's all it is. A shorthand for multiplication. But it also has its own multiplication. Also has its own very important aspects and developments. So we'll go through a couple of those because, again, we're kind of going back in time to an earlier period in our schooling. We're very familiar with something like this where we just do 8 times 8, we get that. So that's a tick, all right? We often overlook the fact that there's a hidden 1 there, and we don't often write the index for 1. We'll write it for 2 and 3 and 4 and so forth, but for 1 we often forget that. Now this is important because it comes up when there's a 1 there. We can use that knowledge as a 1. So we kind of understand 3, and we kind of understand, 5. If we go on and do 5, just writing them next to each other is the same as writing them with a symbol. Okay, we take a lot for granted when we're learning maths. But I wonder what happens if we do a multiplication. So they're not 9s, they're A's. So we know we can go the long way like we did at school, just to remind ourselves. So that's 5 A's. So straight away we would write that here, but I'm going to pause on that. I'm just going to write that up there. And I've left a blank. Why have I done that? So we can do A3 times A5. You can even write it like that. That's not necessary, of course. But I'm just showing you the moving nature of some of this algebra. So we count them all up. 1, 2, 3, 4, 5, 6, 7, 8 in total. A to the 8. Now, why is that important? What's going on here? Why am I making a fuss? Because this is the idea of the forms. Now, a form of an expression, a term, all of those ideas. And in this case here, they're equivalent. They're always equivalent. Okay? So the equivalence points us to a different... Now, think about this. That perhaps is not so significant. Okay? They're equivalent forms. A5 is the same as A2 to 3. Sometimes writing things backwards is very, very important. But there's something that's been missed here. There's another form that's a uniform. I didn't mean that to be a pun. Oops, bad joke. Uniform, university form, university learning, university maths. We'll have our A, and 2 and 3 when added together give you 5. Okay. 3 and 5 when added together give you 8. Now this is profoundly important. That's why I'm spending time on things. I don't waste time. I spend it on things that are important. And in this particular case, the importance of this is that these 2 particular forms score big time in Maths 1. Okay? They are just important. And it's not easy to recognise what it is that I'm babbling on about. Okay? What is that I'm recognising? Okay, what is it that's being recognised? Well, over here in this one, there's 1A, thing on the top. And over here, there's 2A's. 1A, 2A's. It's the indices that make the equivalence. So we need to be aware of that because this comes up. So I'm going to do something now which is very, very naughty of me because we're not doing this as a topic, but I'm going to use this to show you by way of example the kind of thing that happens in Maths 1. So here's a Maths 1 example. So we can say the rate of growth of a population with respect to time, there's a mouthful, is proportional to the population itself. Well, that's a concept you might get in one of the biology or physics classes. In this particular case, we want to equationize that. So we'll say the rate of population n with respect to time is some variable now. It's no longer being proportioned. It's actually being equationed. Still proportional to n. Now this is a particular form that would have come out of 3-unit maths or extension 1. And in actual fact, it's assumed knowledge. So it just goes to show you how far away you can be, but it's never as far knowledge. It's never as far as you actually think. I always tell students they're a lot closer to something than they actually think. So we're going to use a technique called separation of variables. You don't need to learn this at this point. I'm not insisting on that at all. So what that means, I'm going to get the n's together and the t's together. So what that means is I'm going to take divide by, now this is a bit of an equation per peruse here, so I'm going to do it. I'm going to be the annoying long way teacher. Okay, so I'm going to divide by n, both sides. And so you get one in disguise, they cancel, that's another way, some of you have been taught to do that. So you're just left with k on that side, 1 over n, the n dt. Now the separation of variables means I've got to get the t's away, so I'm going to multiply by dt on both sides. So I'm going to have 1 over n dt dn dt. And when we do some basic algebra, I'll do this all again for you. So don't think we're going to march on from this point forward. Look, that's one in disguise. Gone. Okay, so we're left with 1 over n dn. So a bit of algebraic gymnastics, kdt. So that much there, that manipulation is something that you will be expected to be able to do in this subject. Okay, so we're some weeks away from you being able to come back to this and do it, but maybe only a couple of weeks or a few weeks. And of course I'm using more convoluted terms, I'm not using simple numbers or simple ABCs. I'm using unfamiliar algebra, pronumerals of terms. Okay, so the next thing is a bit of a trick here. We integrate. Now I don't expect you to know what that means at all, so don't be alarmed. I'm just doing this for the sake of completeness because I'm interested in what's coming up. Okay, now what's coming up is a one in disguise there, is that this thing becomes the ln of n, and this thing becomes kt plus c, and that something interesting happens here. Now the next line from here to here is one of the 6 things. So one of the 6 things was over here. I should say like 5 of the 6 things here, the 5th one. But what we're going to do is process this functions. I don't expect you to know this today. That's not why I'm doing this. I'm the long way teacher, and I'm just showing you how this works. What you do to one side, you do to the other. I'll show you in the future how to do this. Okay, the thing that I want to draw out, that's a one in disguise. So we're left with the population is E. Now look at this, please. This is the thing I'm interested in you processing. What have we got? We've got 1 with a sum. 1 with a sum. So your challenge now is what is the equivalent form? 2 of them. So this has actually got an equivalent form where there's 2 E's. See? That concept alone pulls down many students when this particular topic is covered. I know this from previous work with students. Okay? So the indices 3 and 5 are added 3 and 5. So if we're adding 3 and 5, we put 3 and 5 separately. So we're going to put KT and C separately. They're the same thing. They're equivalent. Okay, they're equivalent. Now that's a foundation math skill. That's not a maths one skill. That's a foundation math skill. That's indices. We're going to do more on this, so don't be alarmed. Okay, and finally, you may be the constant. This is a constant, so we end up with this familiar old equation. So the number of people is proportional to some constant times another e to the t constant. But the thing that matters the most in this little process is this thing here, the transformation from one form to another. Now that's your job. Your job is to recognize forms. I don't care if you can integrate. I don't care if you followed what I did. But that bit at the bottom here, that's changing forms just like we did up here. It's recognition. They're different. Instead of A, it's E. But the theory is the same. It's exactly the same. Okay? All right. What other things? Now, that's pretty tricky, isn't it? That's university level maths. Okay? Of year 10. Yes, that's right, year 10. The integration and the separation of variables, extension 1. Okay? But this bit here, year 10. That bit there is year 10. You can get hung up on the struggle of going through all of these techniques. This is also year 10. Okay, so I will show you in the coming weeks how to process these indexes. We're going to be very good at gymnastics by the time we're finished. All right, let's change tack a little bit. What about something raised to the power 0? What's something raised to the power? Ask this. Many people knew. 1 or 2 people knew. It's 1. Okay. What about an expression raised to the power of 0? What's it? 1. What about bicycle raised to the power 0? I know that's an absurd form, but you get the idea, right? Raised to the power 0. I think I did the names. Aaron, okay, to the power 0. Jason to the power 0. Okay, bike to the power 0. Car, symbol to the power 0. The concept is anything raised to the power 0 is 1. So we don't want to get away from that. All right. So that's a lot. A lot in indices, isn't there? It's not just, this is all stuff coming out of year 10. All right, so the next thing we want to do is think about what happens when we have a negative. What does that negative mean? And we had an interesting discussion in the lecture about this, and there were some attempts to identify this, but ultimately it comes back to that word idea. That minus sign represents this thing, and that thing is called a reciprocal. So that symbol minus, now by recognition, this is why you're getting taught. So when you see a minus in the future, you also see this reciprocal. Okay? And to finish off the maths of it, the 1's not going to disappear. See where the minus has gone? The minus is still there. It's in equivalent form. These are 2 forms of the same thing. Equivalent form. Now, this is the gymnastics that you're going to have to do well at university. You'll get there. Be patient with yourself. It's something that you can do. Okay? So it's an equivalent form. It's a reciprocal. And we don't normally write 1 over A1, do we? I said that before. That's harder going backwards. What about if we did this one? Going backwards. It's got a reciprocal in it. Instant recognition that a quotient is made up of a reciprocal and its denominator. Reciprocal denominator, reciprocal denominator. So we can replace the reciprocal with a minus index. But before we do that, we need to recognize that there's a 1 there. It's just not visible, 1 in disguise. Now we can do the step. We can do the step and introduce. There's my reciprocal. There's my number. Okay, so let's try it again. Let's do d squared. Well, I don't need to do the intermediate step because that's obvious. So I'm going to make the reciprocal disappear now, Jason. Bye-bye reciprocal. There you are. D to the minus 2. They're equivalent forms. Okay? Often this is the big bugbear for people when they see algebraic terms. Oh, what do I do with it? Well, this can be split up into 2. That's an equivalent form. Why have I pulled that out? Because it's incorporated. The reciprocal is obvious. I've split the fraction. But because it's times, it doesn't matter. There's no special techniques. We'll learn about splitting addition and subtraction fractions at another time. So in that sense there, we're really good. And all we need to do now is change this, get rid of the reciprocal. Those parts of the term still exist. Bye-bye reciprocal, hello minus sign. Okay? So we can still get quite a bit of it. Now going back the other way, of course. 8 E F to the minus 4. How do we process that one? Well, 8E is not going to do anything. But it seems to me that F to the minus 4 is a reciprocal. Bye-bye minus sign, F to the 4. So I can put them together because 8E times 1 is simply 8E. F to the 4. Okay, now you can do this. This is very, very doable. All right, the next thing we touched on, apart from looking at those particular ideas of the reciprocal and the equivalent form, was another equivalent form. And the equivalent form we looked at this time was a fractional indice. What's a fractional indice? And that's a very cheeky thing for me to do there, because many of you will recognise this one. Oh, wait a minute, why have you put that in? What's that got to do with fractional indices? Well, we've been talking about equivalent forms. Are they the equivalent forms of equal? No, not quite. Let's fix this one up a bit. This is the square root to the power 1. Ah, that's important. See, it's not there visible, but in your mathsy eye, your mathsy person's eye, that's exactly what it is. Okay, so this now has an equivalent form, a fractional indice. There's the vinculum. The power of the root goes on the bottom, and the power of the variable goes, or the constant goes there. So there's a link. So what we could do is we could say the 8th, this is getting a bit analysis in now, the 8th root of c to the power b would be c to the power a over b, and normally that's how a textbook would introduce it. But what I'm trying to demonstrate to you is that the curriculum systems that introduce things by definitions like this fall way short of explaining what's going on. Okay? So over here, the thing that we want to recognise is the fraction gives us a symbol. Its equivalent symbol is called a radical. And the radical is this guy here. Okay? So the fractional indice gives us a radical. We induce or invoke this radical symbol by putting this in. Now the denominator sits in the name of the radical, so it's the cube root, and it's b squared. The power goes there like that. Okay, so once you've got the hang of this, not from a definition, but because it's been demonstrated for you, you can go off and finish a number of things. All right, so we could do a to the 5 on 4. Just see if you can write that down. We could do the 5th root of m cubed. What would that form look like? So in this case here, this fractional indice invokes a radical. The denominator is the 4th root, and the 5 goes to the power. There are equivalent forms. Vital. Absolutely vital for you to survive and thrive in Mathematics 1. This one here, the radical, gives us a fractional index. So we're going to have m to the power of a fraction. The 3 goes on the numerator, and the 5 goes on the denominator. They are equivalents. They are the same thing. Okay, same here. All right. So those lessons, I don't think they're terribly onerous or difficult, but they are for some students who've never met this before, and so that can be a bit of a challenge. All right, the final thing we want to do is put them together. This will be the wrap up. So it's good to know that of the 6 things, we've covered 2 of them, adding fractions and indices. How about we have 2 things? It doesn't matter if I change the pronumeral, we've got to get used to that. How about I have minus a over b? I'll just go with that. Ooh. So now we've got 2 pieces of information. That is two pieces of information or two recognition. Okay, first of all, the minus sign gives us a reciprocal. By minus sign. Very good. The fractional indice gives us a radical sign. The denominator is in the name. It's the b through of a to the power root a. Okie dokie. All right. So what about if we have something like this? So we've got recognition of two things happening. There's a reciprocal and there's a radical. So we'll deal with the radical first. So we're going in a slightly different order. You can do whatever order you want, but I'm suggesting the order. Reciprocal up here, radical. Here I'm going to deal with the radical first, leave the reciprocal in play, put in a fractional indice by radical, so the denominator has that. Now you can change that. 6/4 is 2/3. You can change that. It's still equivalent, but I won't do that here. Now I'm going to say by reciprocal, minus 6 on 4. Okay, now just for those that are interested, you can do, they're also an equivalent. Okay, wow, getting used to doing things. Okay, what's that? Well, let's deal with the reciprocal first. The term parts left alone. By reciprocal, there's your minus gone. Y to the 1/3. Okay, there's the first term remaining. The fractional index gives us a radical. It's the cube root of y to the 1. And I didn't even need to write that. And I can put that on the top. Why do we need this? We need it in calculus. We need to be able to do the gymnastics in calculus. Okay, what about if we have a 5m over the 9th root of n2? Now, our temptation is to do, we know there's a cancelling thing that happens, but I'm not going to do that here. We'll work the maths of that out later. Well, I'm going to deal with the radical. So first step, put the fractional index in. The denominator is the 9. 2/9. There you go. Same thing. Radical's gone. Goodbye reciprocal. By the reciprocal, I mean that we have this. Now you could have missed that step if you'd wanted to, but me being the complete way, I'm going to say bye-bye, Mr. Reciprocal, in to the minus 2 on 9. And that's your final result. And that is the same as that. Now you can see why maths is hard. Maths is hard at uni. It's got nothing to do with calculus and it has everything to do with gymnastics. Okay, so we'll do some more work on that, but I'd like you to try and find some practice ideas that you can do. You can write out some examples yourself and use technology. I'm going to introduce that next week again, so that you can serve your practice yourself. But it's enough here that you just do these, redo them again, see if you can step through it in your own way. Some of you will be jumping off completely. All right, we'll come back to this in a new video, which I'll do now.